Good afternoon, everyone. My name is Kavitha. I am from CSM department, working as a assistant professor of Marri Laxman Reddy Institute of Technology and Management. Today, I am going to teach about the subject is distributed systems. So, first is the course objectives to understand what and why a distributed system, to understand theoretical concepts, namely virtual time, agreement, and consensus protocols, to understand IPC, group communication, and RPC concepts, to understand the distributed file share and distributed shared memory concepts, to understand the concepts of transaction in distributed environment and associated concepts, namely concurrency control, deadlocks, and error recovery. Coming to the course outcomes, student will be able to comprehend and design a new distributed system with the desired features, able to start literature survey leading to further research in any sub area, able to develop new distributed applications, right? So coming to the syllabus, in distributed system we have 5 units and each and every system following two parts, right? So the first unit is the characterization of distributed systems. In that we have contents, introduction, example of distributed systems, resource sharing, and the web challenges. And second part is system models, introduction, architectural models, fundamental models. So this is the first unit. So this unit is mainly focused on what distributed systems are and why they are built and the blueprints used to design them. And second unit is this is about synchronization, right? So the second unit is time and global states. So in that we have content, introduction, clock events and process states, synchronizing physical clocks, logical time and logical clocks, global states, distributed debugging. And second one is coordination and agreement. Introduction, distributed mutual exclusion, elections, multicast communication, consensus, and related problem. So this unit is mainly introduces on how distributed systems manage time and coordinate across multiple systems and communicate efficiently and reach agreement and while ensuring consistency and correctness across different computers, right? So next is the third unit is interprocess communication. In that we have contents, introduction, the API for the internet protocols, external data representation and marshalling, client server communication, group communication, case study, IPC in Unix, distributed objects and remote invocation. In that we have introduction, communication between distributed objects, remote procedure call, events and notifications. And case study is a Java RMI. So is this unit covers how data moves over a networks in a distributed system and how programs invoke operations on remote machines, right? And third and the fourth unit is distributed file systems. So in that we have introduction, file service architecture, And case study 1, Sun Network File System. Case study 2, the Android File System. Name services, introduction, name, services and the domain name system, directory services, case study of the global name services. Okay, so this is the fourth unit. This unit explains how data storage is scaled and shared across a network transparently, right? So the last unit is transactions and concurrency control. Introduction, transactions, nested transactions, logs, optimistic concurrency control, timestamp ordering, comparison of methods for concurrency control. And the distributed transactions, about the introduction, flat and nested distributed transactions, atomic commit protocols, concurrency control in distributed transactions, distributed deadlocks, transaction recovery. So, in the distributed system, this is the last unit, that is the fifth unit. Okay, so this unit is mainly focus on managing transactions safely in distributed system, right? By controlling concurrent process, communicating consistency and maintaining coordination transaction across multiple systems, ensuring recovery from failures, right? So this is all the five units covered in the distributed systems, right? First, the introduction about the distributed system, right? So network of computers are everywhere, right? So the internet is one, as are the many compute networks of which it is composed. Mobile phone networks, corporate networks, factory networks, campus networks, home networks, in car networks, all of this. So both separately and in combination share the essential characteristics that make them relevant subjects for study under the handling heading distributed systems. Right? Distributed system is a one in which hardware or software components located at networked computers communicate and coordinate their actions only by sending the messages. This simple definition covers the entire range of systems in which networked computers can usefully be deployed. Now the definition of distributed system. Right. So the distributed system, the main concept is the single problem solved with the multiple computers. Right. So in that definition, a distributed is a collection of independent computers called nodes or components or workstations that are connected by a network and communicate by passing messages to coordinate their actions. To users and applications, such a system typically appears as a single coherent system. Even though the hardware and software are spread across multiple machines. So, distributed system. Distributed system is a collection of autonomous computers that work together as a single coherent. So, these computers connected through a networks and communicate by sending message to each other. Instead of centralized machine doing all the work, multiple tasks making the system faster, scalable and reliable, right? Suppose there are different computers, right? Different computers means independent computers connected through a network, right? And communicate to each other by sending the message, right? So instead of centralized system, means suppose one main server and all the computers connected through a network to the main server, right? So all these all systems resources located in the main servers, right? So for example, online banking system or online shopping websites, when create a one website like Amazon or Misho, right? So we have different computers communicate and by using the messages like request response, right? So here like front end server, back end server, database server, payment server. So these are all the different computers communicate through messages, right? So suppose another example, application WhatsApp application, right? So here when you send a message your phone and that message forward to the WhatsApp server and WhatsApp server forward to the friend phone. Okay, so here there are three different computers communicate through messages, right? So and principles of distributed system means autonomous computers. Autonomous computers means independent computers, and network connectivity means all the computers connected through network. Middleware, middleware, middleware software is installed in the all independent computers by using the connection purpose and network communication and coordination, right? So resource sharing and sharing resource sharing means sharing the information through hardware components, right? And transparency means single system view, right? So this is about the distributed system definition. So here see the diagram, there are three independent computers and we have a distributed system layer, that is the middleware software, and each and every system have local operating system. So the whole system will be connected through network, right? So this is the distributed system diagram. Next, characteristics of distributed system. Characteristics of distributed system means distributed systems are characterized by concurrency, no global clock, and independent failures. These three properties together define how components coordinate, timestamp events, and tolerate faults. In that we have three main characteristics, that is the concurrency, no global clock, independent failures. So first is the concurrency. Concurrency means parallelly working, means multiple processes execute at the same time across nodes. For example, two users trying to buy the last item on an e-commerce site, right? For example, online shopping site. So here user A and user B both try to buy the last item in stock at the same time, right? So two servers, server 1 and server 2, receive their orders and both try to decrement the stock count. Suppose user A means server 1, user B means server 2. So user A, server 1 reads stock 1 and also user B, server 2 reads stock 1. Here both servers decrement stock means result is 0, but both think they bought it. Suppose concurrency means multiple tasks or multiple processor run at the same time. For example, in an online banking system, many users can perform money transfers, bank balance checks, and bill payment at the same time, right? And also in Google Drive, two users edit the same file simultaneously. That means multiple tasks happen in parallel at the same time. So that is the concurrency, right? And second one is the no global clock. Here, in a distributed system, there is no single perfect global clock that all machines agree on. So each node has its own local clock, and these clocks can drift or run at slightly different speeds. For example, bank branches in different cities with unsynchronized clocks. For example, bank transfers between branches, right? So here branch A in Hyderabad and branch B in Mumbai. So each have their own clocks, right? So a customer transfers money at 10:05. It is a local time at branch A. The message reaches branch B at its local time 10:04. So here because of clock skew is so here showing time variation, right? Suppose branch A Hyderabad, right? So time is 10:05, transaction A. Here sometimes network delay, the branch B Mumbai time is 10:04. So transaction B recorded earlier. Means no global clock, means here there is no single shared common clock by all computers in a distributed system. Means different servers in different locations show slightly different times, right? So this is a no global clock, right? Independent values, right? So here in a distributed system, each component can fail independently while others keep running. This means one machine, network link, or service can crash, hang, or become slow, but the rest of the system should still function. For example, a web application runs on three servers, Web 1, Web 2, Web 3, right? Web 2 crashes due to a hardware fault, but Web 1 and Web 3 are still live. So here a load balancer redirects new request to the working servers. So the system continues to accept user request. Here, for example, cloud service with multiple servers. Suppose client load balancer. So here web 1 okay, web 2 crashed, web 3 okay. So here means independent failure means Each component in a distributed system can fail independently without affecting others, right? So here each component in a distributed system can fail independently without affecting others, right? So this is the independent failures, right? And next is the examples of distributed systems. A distributed system is a collection of independent computers that work together over a network and appear to users as one system, right? So, example of distributed system is the internet, intranet, and the mobile computing. Here, the internet. So, already know about this. Okay, so the internet is a global distributed system made up of many interconnected networks that use common communication protocols, mainly TCP or IP, to exchange data. It is not owned by one organization. Instead, many networks, servers, routers, and service providers work together as one hug system, right? So here the internet is a worldwide network that connects millions of computers and devices, right? So it is allows to share information, communicate, browse websites, and watching videos, and sending mails, emails, and use online services. So this is the internet. So, but how it is work? How it is works? A user's device sends a request, such as opening a website. The request passes through routers and network links. One of many distributed servers responds with the data. If one server is busy, another server or a nearby copy may respond, which improves speed and reliability. Right? For example, searching information on Google, watching videos on YouTube, and sending mails using Gmail. So, this is the internet information, right? And examples of internet web browsing, such as visiting Wikipedia or Google, email services, cloud storage services like Google Drive or Dropbox, video streaming platforms like YouTube and Netflix. So, and next is the intranet. Intranet means an intranet is a private network and used inside an organization, built using internet technologies but restricted to authorized users only. It is administered separately and protected by security controls such as routers and firewalls, right? So here intranet. So intranet is a private network that used within an organization. Only authorized employees or members can access it. Right? So it is used to share company information, files, notice, and internal communication. Right? So for example, hello. So for example, the college portal where only students and staff login, and also a company employee portal. So this is the example of intranet, right? And then how it is work? Employees connect to internal servers Through the organization's network, the intranet provides access to internal files, emails, database, and applications. Firewalls filter incoming and outgoing traffic to protect internal resources. Examples of intranet: a company portal for employees, a university intranet for students and staff, internal HR systems, payroll systems, and document sharing platforms. So, the last is the mobile computing. Mobile computing means the mobile computing, the mobile computing means performing computing tasks while the user is moving away from the home network using portable devices such as smartphones, tablets, laptops, and wearables. It depends on wireless communication and access to networked resources from different locations. Mobile computing. Mobile computing is a using portable devices and used to access uh, information anytime and anywhere, right? So, such as smartphones, laptops, washing machine, while moves from one place to another place. And how it works? A mobile device connects through Wi-Fi, cellular data, or another wireless network. The device communicates with remote servers on the internet or on the user's home intranet. The user can continue using services even while traveling or changing location. Right? For example, using using WhatsApp on smartphones. Right? So online banking system in mobile app, and also another example, attend online classes on laptops with Wi-Fi. So here examples like checking email on a smartphone while traveling, using mobile banking from anywhere, accessing a company VPN and internal files from home, location based services like maps and ride hailing apps. So, the end of the session. Thank you.